JIT and lean operation. JIT stands for just in time. Familiar, right? Just in time. Why is just in time? An approach of continuous and forced problem solving. And it says high volume, minimal inventory. High volume, minimum inventory. Produce more using less inventory. Okay, inventory can be unnecessary things. If we can reduce inventory, then we can save cost, right? Nothing will be produced until it is needed. Make to order system. JIT system is make to order system. Make to order system. And make to order system is pull system. Make to order system is pull system. I will tell you why. Pull system, inventory are pulled through the system by actual demand. Make to order system. Okay. Make to order system. Make to order system. Wait until a customer place an order, right? Then act. Customer place order, right? An order. Then this doesn't have product because it's make to order system. This final process asks part. I need a part. I need a part. This one asks, I need a part. This one asks, I need a part. So, ask part and then pull. So, inventory are pulled. I need pull, right? So, make to order system is pull system, and JIT system is make to order system and pull system. I need a part, I need a part. How about push system? Push system, demand is forecast. Forecast, and then we know future demand. Like we know due date, right? Earlier we talked about that. Make to stock system, make to stock system. Here, from a supplier side, they know future demand, right? Just make and send down. So, inventory, push it, right? So, make to stock system is push system. We will talk about we will cover MRP system later. We call a conventional or traditional system, that is push system and make to stock system. So JIT system, make to order system, and pull system. Conventional, traditional MRP system is make to stock system and push system. The elimination of waste in production effort. Okay, in manufacturing company, production company, what can be waste? Unnecessary things. Unnecessary space, such as inventory space. unnecessary employee, unnecessary time, such as waiting time, setup time. So many unnecessary things, time, cost, and so on, space, and so on, right? Reduce or eliminate unnecessary things, waste in this system, JIT system. The timing of production resources. Time is important in JIT system. If I need 100 now, but it comes tomorrow. It comes tomorrow. 1 day wait, right? Waiting time. Just in time, if I need 100 now, receive 100 now. Then we don't need inventory, we don't need waiting time, we don't need something unnecessary things, right? Time is important. So we call just-in-time system. Toyota system is the most famous JIT system. Let's talk about how Toyota production system eliminate waste. Focused factory networks. Nowadays, most production company use this focused factory network. 85 like this, right? Here Montgomery, and here Phoenix City here, right? And this is Boulder, and here Kia. Here Hyundai, this is 65, I-65, and then this one is I-85. Phoenix City here. Near Hyundai, there are so many suppliers. Near Kia and along 85 suppliers like this. Maybe they supplier connected each other, most connected like Hyundai. Some are connected, they themselves connect like this. Looks like a network, right? We call this focused factory network. Focused factory, sometimes only one type of product for an entire facility. One of the supplier, company name is Pyeonghwa. The company produce only door panel, the electric things inside, the switch, the circuit inside. And another company name is Hanil. Pyeonghwa here and Hanil is about here. This Hanil company produce the outside door panel. So two companies combine the door, the outside panel, inside the circuit and panel, and then they connect and then send to Hyundai like this. So this company produce only inside the circuit and panel. This one outside. Certain company, the name is Daehan. The company produce inside the interior things. Then produce and send. Only one, and sometimes two types. Why manufacturing main company use like this? Why? They are outsourcing.
Yeah,
Right?
so it's cheaper.
Near the main company, they place like this. How about delivery time? Fast, right?
Mm-hmm.
And then they produce only one. Maybe good quality, right?
Mhm.
Better. Cheaper too. So using this focus factory network, they eliminate unnecessary time, waiting time, lead time, and so on. Right? This is one of the methods to eliminate unnecessary things, waste. And next one, group technology. Do you remember? From a functional type or department type layout, change to cellular layout using group technology. Okay, using group technology, what can be benefit? Before using group technology, department type has complicate, right? Using cellular layout, simple, right? Simplify, save time, right? Shorter distance moving. So using group technology, we can save time and cost. Quality at the source. Inspection at the source. And from outside suppliers, send, receive, part, and then produce like this, right? Okay. Suppliers, after finish, inspect, and then 100% sure, then send. This one receive, without inspection, produce right away. Trust. Then this one doesn't need another inspection time, right? So reduce throughput time, right? So using quality at the source. Hyundai use this one too. Hyundai use this one too. And JIT production, if something satisfied, then we can call that is JIT production. If we can receive right amount. If I need 100, receive 100. We don't need inventory, right? If we receive something at the right time, we don't need wait, right? And then smaller size. If we need 100, but we receive 1,000, we need inventory, right? But even now we cannot eliminate entire inventory. If we can reduce inventory size, we can save, right, the cost. So order small by small, right? So JIT system need small order, small by small. Then if we can do these things, satisfy right amount, receive right amount, right time, at right time, and small lot, order small by small, then we can make low or virtually no inventory. So JIT system using minimal inventory produce more and large. Uniform plant loading, firm monthly production plan. First month 150, schedule 150. Second month 50. Third month 100. 150 more. What's the problem?
Not consistent.
We need 150 capacity, then 100 waste, 50 waste, right? If we can schedule 100, 100, 100, we need 100 capacity, but the total is 300, the same, right? So 50 capacity is waste, right? So using uniform plant loading in Japanese Eijunka, we can save cost, right? Kanban production control system. Kanban system I have water dispenser, the 5-gallon water. I use 4 containers. So one is on the dispenser, and there are 3 waters. Change. Then 2 empty bottles. I go, then buy 2 empty bottle means buy
more.
right? That is sign, right? That tells me, right? Go to the store, right? That is Kanban system. Kanban system using signs such as instruction card, container, Kanban squares, color, golf ball, whatever ball, to signal the need for production of parts. I need empty. If a system process between 2 stages, use 2 containers as Kanban. When they start, parts are full like this. This one use this part. When it's empty, maybe there is sensor here, send signal. I need part. then this one more.
Field.
While this one is filled, this one use this part. And when it's full, maybe this one is empty, then this one sends the signal and fill. This is Kanban system. So at my home, using the empty bottle as Kanban, what's benefit?
You don't run out.
Never run out, right?
Mhm.
Never run out the part,
Mhm.
right? So eliminate something waiting time, right? Unnecessary time.
Mhm.
That is Kanban system. Minimize setup time. Setup means when we produce different preparing time, right? How can we reduce or get rid of setup time? Scheduling, right? A, B, A, B, A, B, B, right? Or using own separate process line, right? Production line. Then we can reduce setup time. Then implementation requirement. Okay, to use JIT system, some requirement. There are some requirement. Lean layout and design flow. Link operation balance. Link operations. Usually, JIT system process is line type. Link each other. And then balance workstation capacity. Do you remember? Capacity is 150, 100, then total system capacity is 50 because of this one, right?
That's right.
So improve this one, balancing, then this one will be 100. No waste, right? Redesign layout for flow. If process is not line type, redesign line type, then flow. And emphasize preventive maintenance. Okay, malfunction, breakdown, and wait, right? So preventive maintenance, prevention management needed, right? Check and maintenance. And reduce setup and change over time, same story. And then reduce lot size. JIT system needs small lot size. Reduce lot size. This one shows large lot and small lot size. JIT system using Kanban system. Small lot size, maybe we can reduce cost because we don't need inventory and so on. So smaller size, using smaller size can reduce cost. And lean application for workstation shops. Workstation types. When we talked about layout, workstation type, functional department type, when low volume, high variety, each product volume is not many, but different type, many different types of. That is customization. This situation, we cannot use a JIT system because many different types of product, low volume, but demand is stable, we can use the JIT system in this types of system. So, if we can control demand and then make it stable, then we can use JIT system. If we cannot, then we cannot use JIT system in workstation type. Six Sigma quality, we did Six Sigma, right? 1 out of a million or 2 out of billion. Worker responsibility, work at inspection at the source. Worker has responsibility of the product. Okay. And then using statistical quality control, something statistical method control. Equal X bar chart, R chart, and so on. And then fail-safe method, using fail-safe method. Do you remember fail-safe method? Different the plug type, 220 Asia, here one different types. And the automatic inspection, if we can use automatic inspection, then we can use JIT system. Stable schedule, we talked about stable schedule, same, 100, 100, 100. Underutilized capacity, do you remember best operating level? Best operating level. And establish freeze windows. Okay. Usually, manufacturing company use one month freeze window. Schedule future production. Next month, next month, next month, like this. Longer than 1, 2 or more months, they can change. But closer to the schedule, don't change. So using 1 month, usually 1 month window freeze. If they change, then production scheduling may be messed up. So using freeze window. And work with the suppliers. Reduce lead time. Focus factory network near the main company. You reduce lead time. Frequent delivery, because JIT system using smaller size, order small by small. So delivery frequently. And then project usage requirement. When they develop new product, work with the suppliers. And then quality expectation, quality at the source, inspection at the source, trust their products, quality, and then without inspection, again, just produce. That's all for chapter 16. And chapter 17, not very long. It's about maintenance and reliability. These two chapters, 16 and 17, very boring, so please be patient. Maintenance and reliability. Why we need maintenance? The breakdown and malfunction, we need a repair, then we wait, right? So maintenance is important. Maintenance is the objective of maintenance, and reliability is to remain, maintain the capability of the system, always run, right? Without breakdown. Maintenance means all activities involved in keeping systems, equipment in working order. So, keeping the system work. Okay, for maintenance, employee involvement and something process. Employee partnering with maintenance personnel. Okay. When I make the copy, department has a copy machine, and then on the wall, in case something, then there is contact number. So if copy machine doesn't work, then call right away. So reduce the time. And then skill training. Sometimes jam. That is minor, right? Then call. If I can fix that, then we don't wait, we don't call, right? So skilled employee need, right? So I can do, then it says the number, then the part, okay, open, and then. And also rewards, if they can do well, then reward. Employee empowerment. When I went to Saudi Arabia, not this time, but earlier, Troy University has something program there. So I went to, the city name was Jubail, Saudi Arabia. Is northeast part of Saudi Arabia. That school has a very nice building and nice classroom, and then computer lab. I taught 2 classes there, statistics and operations management. It's at graduate level. When I taught, I teach statistics using Excel, Microsoft Excel, but we need add in something program. But I couldn't. Student couldn't install that add-in because there was no authorization. So call every time we need something, and technician come and then install every computer every time. If we have authorization, empowered, we can do. We don't need to wait. We can do it, right? So train employee and then give them authorization, empowerment. And clean, and so on. Then result, reduce inventory, improve quality, and so on. That means make it better, cheaper, faster. Reliability. The probability that a machine will function properly for a specific time. Okay. Your car, turn on engine every time, then you go. But sometimes, reliability is not good, right? Earlier, Hyundai, like 1980 and 1990, about that time, Hyundai cars commercial was reliable car. Before that, Hyundai car was not reliable.
Hmm.
Now Hyundai car is good, but that time the problem was reliability. Okay, reliability. Improving individual components, then the total system reliability improve. Reliability is kind of multiplication. Individual reliability is 90%, 80%, 99%. Then the system reliability is only 71.3%. It's multiplication. So to improve system reliability, we need improve individual reliability. So if like the number of employee or the number of parts, more parts or more employee, it changed a lot. Individual and then system. So we need, remember to improve quality, reduce the number of parts, right? The same. Reliability, only one, then it's the same, but two, more, and so on, then it moves like exponentially. If we improve individual reliability, then improve the system reliability exponentially. Okay, and then types of maintenance: preventive maintenance, breakdown maintenance, predictive maintenance. Preventive, routine. Before that happen, we maintain. And the breakdown maintenance, when it's breakdown, then repair. Predictive, using advanced technology, something using a monitor. Nowadays cars using this kind of, it gives some information, right? Okay. Breakdown. When it's breakdown, then maintenance, then advantage, no prior work. But disadvantage, when it's breakdown, we should wait and then something waste. And preventive, work can be scheduled, every month. It depends on the oil change. If you go some local oil change station shop, then they recommend 3,000 miles. I go dealer, then dealer recommend 7,500 miles. I don't know why it's different. Anyway, every 3,000 oil, every 5,000 change oil. That is preventive. Schedule, right? And disadvantage, because it's scheduling, we pay, right? So cost. And predictive, using certain sensor or something, then it's not scheduled. When we receive something signal, sign, then do it, right? So, but disadvantage, the same, cost, and such. Like an office copier, usually we use breakdown when it's jamming or something happen, then call and then come and then plant machine, usually like a car oil change using a preventive, and some others using sensor, then some symptom, then using this predictive, such. And then how can we improve? We told train and resource and ability, train and then ability improve. And then oscillation, and this one also ability to identify the cause of breakdown by a train, we can do it, or using something device, sensor and so on. And then MTBF, mean time between failure. If we have, if the quality is improved, then the maintenance time longer, right? Mean time between failure longer, so on. That's all for chapter 16 and 17. Thanks for your patience. Okay, that's all. And then next 2 weeks, no class. See you 2 weeks later. I will miss you.
Have a good Thanksgiving.